Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter solutions. So any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Um, Also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told which of the following can be measured by the Oswald-Walker dynamic method. So Oswald-Walker dynamic method, it is used to m- used for the measurement of relative lowering of vapor pressure. So relative lowering of vapor pressure, that is measured using the Oswald-Walker dynamic m- method. So option B is the correct answer. Then here it is told a vapor pressure of pure A, vapor pressure of pure A, it means that P naught A, that is equal to 70 millimeter of mercury column at 25 degrees Celsius. It forms an ideal solution with B in which mole fraction of A, so the mole fraction, we can write it chi, the mole, the mole fraction of A is 0.8. If the vapor pressure of the solution, the vapor pressure of the solution, that is P is equal to 84 millimeter of mercury column, which is at 25 degrees Celsius. Then the vapor pressure of pure B, that is 25 degree. Okay. The vapor pressure of pure B that has been asked at 25 degrees Celsius. So now according to the Raoult's law, so from here it means that um, so we have a mixture of A and B only, the solution of A and B. So it means since the mole fraction of A is 0.8, so mole fraction of B will be 0.2. Since why the mole fractions of the two components, their sum should be 1. The sum of the mole fractions of all the components, that should be equal to 1. So now according to the Raoult's law, so according to Raoult's law, we can say that the vapor pressure of the solution, that is equals to P naught A times chi A plus P naught B into chi B. So therefore 84 millimeter of mercury column. So that is equal to 70 into chi A, that is 0.8, plus P naught B, which you have to find, P naught B into 0.2. So therefore you can say that 84, that is equal to 7 8 is 56. So 56 plus 0.2 into P naught B. So therefore P naught B, that will be equal to 84 minus 56 divided by 0.2. This much millimeter of mercury column. So that will be equal to 84 minus 56, that is 828 by 0.2. So that will be 140. 140 millimeter of mercury column. So it is the vapor pressure of P or B. So option C is the correct answer. Then here it is told a 6% solution of urea is isotonic with how much? So, so what should be the concentration of the glucose solution with which this solution of urea is isotonic? So for isotonic solution, we should have for isotonic solution, uh, the concentration of glucose. So it means that if the solution, so for two isotonic solutions, if the solution 1 is isotonic with solution 2, then pi 1 should be equal to pi 2. It means that the concentration of the first solution should be equal to the concentration of the second solution. Or I can say, so it means the molar concentration of the first solution should be equal to the molar concentration of the second solution. So now, therefore, it means the concent molar concentration of the glucose solution that should be equal to the molar concentration of the urea solution. So now the mass of glucose, let's say the weight of glucose that should be taken, that is Wg, divided by molar mass of glucose into the volume. So, so let's say 100 ml of solution is used, 100 ml of both the glucose solution and the urea solution is being used. So 100 ml means 100 by 1000 liters has been used. So it will be the molar concentration of glucose, and that should be equal to the molar concentration of urea. So weight of urea by molar mass of urea again into 10 100 by 1000. So 100 by 1000 will cancel out. So then it means let's say we take x gram of glucose, and x gram divided by molar mass of glucose, m- molar mass of glucose which should be used, that is equal to, so glucose is C6H12O6. So it's, so molar mass of glucose will be 6 to the 12. Uh, uh, no, I can say for hydrogen it is 1, so 12 into 1, plus for carbon it is 12 plus 6 into 16. So this will be 12 plus 12 is 72 plus 16 6 are 96. So if you solve it, then we will get it as 180 gram. So x by 180, that is equals to the So 6% urea solution, 6% urea solution, it means that 6 gram of urea is present in is is present 6 gram of urea is present in 100 ml of solution, 100 ml of solution. So it means that 6 gram divided by molar mass of urea. Now for urea is CO CONH2 whole 2, which is NH2CONH2. So therefore it's so the molar mass of urea, that will be equal to 14 plus 2 into 2 plus carbon, that is 12, plus oxygen, that is 16. So 16 to 2, 32, 32 plus 28. So that will be 60 gram. So 6 by 60 into 100 by 1000. Okay. So we have to find out x. So therefore x by 180, that is equal to 6 by 60. So which is 1 by 10. So x will be equal to 18. So 18 gram of glucose has been used. So therefore it means that 18 gram of glucose is present. 10 gram of glucose is present in 100 ml of solution. So therefore the molar concentration or the molarity of the glucose solution, molarity of the glucose solution, that will be equal to the number of moles of glucose, that is 18 by 180 divided by volume in liters, so 100 by 1000. So this much molar. So this will be 1 by 10 into 10 by 1. So this will be 1 molar. 1 by 10. Okay. So 1 molar of glucose solution is isotonic with 6% of urea solution. So option D is the correct answer. Then it is told that in countries nearer to polar regions, the roads are sprinkled with calcium chloride. This is to uh, this is to minimize the snowfall only. Since why CaCl2 acts as a non-volatile solute. Acts as a non-volatile solute, and it results in the depression in the freezing point. It causes depression in the freezing point. Depression in the freezing point, and so the snowfall will be reduced. So the snowfall is reduced, and which prevents the blockage of the roads. So it means that option A is the correct answer. The empirical formula of a non-electrolyte is CH2O. So it means the molecular formula, the molecular formula will be CH2O whole N, where N we have to find out. Since CH2O is the empirical formula. A solution containing 6 gram of the compound exerts the same osmotic pressure as that of 0.05 molar glucose solution at the same temperature. the molecular formula of the compound is. So here also it means that 6 gram of the compound exert the same osmotic pressure exerts same osmotic pressure as that of the 0.05 molar glucose solution same temperature at the same temperature. So it means that so it means the osmotic pressure is same. It means that pi 1 equals to pi 2. So it means there, so the two solutions will be isotonic. So the two solutions, so the solutions are isotonic. It means their concentration should be same. It means their molar concentration should be the same. C1 should be equal to C2. So therefore, it means that yeah. So therefore, it means that the molar concentration, so 0.05 molar glucose, it means that 0.05 moles of glucose is present in 1 liter of solution, and that should be equal to the molar concentration of this compound. So it means here the molar mass of this compound, m- molar mass of this compound, let's call it as M2, that will be equal to 12 plus 2 plus 16 into n. So that will be, so 12 plus 2 plus 16, which is 14 plus 16, that is 30. So 30 is the empirical formula mass of this compound. So 30n is the molar mass of this compound. So therefore, the mass of the compound that is used, that is 6 grams. So 6 by 30n, this is the number of moles, divided by the volume. Let's say the volume taken is 1 liter only. So from here we can obtain n. So therefore 5 by 100. 0.05 means 5 by 100, that is equals to 6 by 30n. So 6 5s are 30. So it means that from here we can see that 25n, that is equals to 100. So n equals to 4. N equals to 4. Therefore, the molecular formula, the molecular formula of this compound, that is equal to CH2O. So that is equal to CH2O whole into 4. So that will be equal to C4H8O4. C4H8O4. So option D is the correct answer. Yeah. Then here it is told that the empirical formula of a non-electrolyte, the empirical formula of a non-electrolyte is CH2O. So it means its molecular formula will be of the form CH2O whole n, and a solution containing 3 gram of that compound exerts the same osmotic pressure as that of 0.05 molar glucose solution. So 3 gram of that compounds, so solution containing 3 gram of the compound exerts the same exert same osmotic pressure, exert same osmotic pressure um, as that of 0.05 molar glucose solution. 0.05 molar glucose solution. So therefore it means pi 1 equals to pi 2. It means their osmotic pressure is the same. So osmotic pressure is same osmotic pressure they are exerting. It means that their molar concentration also should be same. It means C1 should be equal to C2. So now the molar concentration of the glucose solution is 0.05, and that should be equal to the molar concentration of the compound. So now from here, the molar mass of this compound, that is M2, let's say, so that will be equal to 12 plus 2 plus 16 into N, that is equal to 30N. So here actually this 30 is the empirical formula mass. Empirical formula mass is 30 gram. Yeah. So molar mass is 30 N gram. So from here N we have to find out. So the molar concentration of the compound, that is 3 gram divided by 30 N gram into, let's say we take 1 liter as the volume of the compound. 1 liter of the volume of the compound is used. So then from here we have to find out N. So therefore 0.05 means 5 by 100, that is equals to 3 by 30N. So that is 10N. So 50N, that is equals to 100. So therefore N equals to 2. So therefore the molecular formula of that compound which we have to find out. Therefore the molecular formula of the compound, that is equal to CH2O whole 2. So which is equal to C2H4O2. C2H4O2. So option B is the correct answer. Then here it is told that a solution of two liquid boils at a temperature more than the boiling point of either of them. Hence the binary solution shows. So a solution of two liquids. Okay. So the rule is that those solutions, those solutions which boil, those solutions which boil at a relatively higher temperature, at a relatively higher temperature, mm, it means that it means the vapor pressure of the solution is less. It means the vapor pressure of the solution is less, and then it will show negative deviation from Raoult's law. Then it will show negative deviation from Raoult's law. Negative deviation from Raoult's law. So here also it means a solution of two liquids boils at a temperature more than the boiling point of either of them. So it means the solution which boil at relatively higher temperature, it means the temperature of the, if it happens that the temperature of the, if it means that if the boiling point of the mixture is higher than the boiling point of any of its components, boiling point of any of its components, then only it means that the solution will show negative deviation from Raoult's law. So option A is the correct answer. Then it then here it is told that the mass of a non-volatile solute of molar mass 40 gram per mole. The mass of a non-volatile solute, the mass of a non-volatile, the mass of a non-volatile solute of molar mass is 40 gram per mole. That should be dissolved in 114 gram of octane. 114 gram of octane to lower its vapor pressure by 20%. Um, uh, 114 gram of o- o- octane to lower its vapor pressure by 20%. Um, so, so here it means the non-volatile solute should be dissolved in 114 gram of octane. So with octane it should be mixed so as to lower the vapor pressure by 20%. So here also Raoult's law, according to Raoult's law, according to Raoult's law, we can say that P naught minus Ps, it means the vapor pressure of the pure solvent minus the vapor pressure of this solution divided by the vapor pressure of the pure solvent, that into 100%. So that is equal to the relative lowering of vapor pressure. Relative lowering of vapor pressure. So relative lowering of vapor pressure of the solution, that is equal to P naught minus Ps by P naught into 100%. So where P naught is the vapor pressure, vapor pressure of the pure solvent, Ps is the vapor pressure of the solution, vapor pressure of the solution. Okay, so here, as we know that so now, so according to the Raoult's law, P naught minus Ps divided by P naught, that will be equal to weight of the solute, weight of the solute, let's call it as W1 by molar mass of the solute divided by weight of the solute by molar mass of the solute plus the weight of the solvent by molar mass of the solvent. Since y simply P naught minus Ps, P naught minus Ps by P naught, that I can say it as the mole fraction of the solute. Mole fraction of the solute, it means the number of moles of the solute divided by the number of moles of the mixture, which is equal to the number of moles of solute plus number of moles of solvent. So it means if you want to find the number of moles of solute, that is equal to weight of the solute by molar mass of the solute by weight of the solute by molar mass of the solute plus weight of the solvent by molar mass of the solvent. So that will be equal to, so that should be equal to 20%, it is told. So it is 20 by 100. It is 0.2. So hence it means that weight of the solute, that should be used, that we have to find out. So here W1 only we have to find out. So it means that W1 by molar mass of the solute, that is equal to 40 gram. 40 divided by W1 by 40 plus weight of the solvent, that is 114 gram. 114 gram. 114 gram. And for octane we have to find the molar mass. Now the molar mass of octane, as we know, that is equal to C8H, so it's a 16 plus, okay, C8H18. So it will be 18 plus 8 into 12. 12 8 is a 96 plus 18, so that will be equal to 114 only. 114 gram per mole. So therefore 114 by 114, so that should be equal to 0.2, that is told. So it will be W1 by 40, that is equal to 0.2 plus, so 0.2 into 1 plus W, so this will be 1 only, W1 by 40. So this will be W1 by 40 into 1 minus 0.2, that should be equal to 0.2. So therefore W1, that will be equal to 0.2 into 40 divided by, this will be 0.8. So point can be removed, so 2 4s 8, so 4 10s are 40, so 10 gram. So it means that 10 gram of this solute should be used. So option A is the correct answer. Then here it is told the vapor pressures of two liquids A and B in their pure states are in the ratio of 1:2. A binary solution of A and B contains A and B in the mole proportion of 1:2. The mole fraction of A in the vapor phase of the solution will be. The vapor pressures of two liquids A and B in their pure states are in the ratio of 1:2. So the vapor pressure of A in their pure state, that is equal to, suppose x mm of Ag, suppose, and the vapor pressure of the liquid B in their pure state, that is 2x mm of Hg. Then a binary solution of A and B contains A and B in the mole proportion of 1:2. So therefore the mole fraction of A, that will be equal to 1 by 1 plus 2, that is 3. And the mole fraction of B, that will be equal to 2 by 3. Now the mole fraction of A in the vapor phase of the solution will be. Mole fraction of A. Uh, so the mole fraction of A in the vapor phase. Now, so now the mole fraction of A in the vapor phase, that will be equal to P naught A by P naught A plus P naught B. So that will be x by x plus 2x. So that will be equal to 1 by 3 only. So that will be equal to 0.33. So option A is the correct answer. Then it is told which of the following is not a colligative property. So uh, elevation in boiling point, depression in freezing point, osmotic pressure, all these are um, colligative properties. So the thing is that relative lowering of vapor pressure is a colligative property, but simply lowering of vapor pressure is not a colligative property. So relative lowering of vapor pressure re- relative lowering of vapor pressure is a colligative property. It is a colligative property it since it depends only on the number of moles of the solute, only on the number of moles of the solute and the solvent, and it is independent of the nature of the solute, and is independent of the nature of solute. But here it is told lowering of vapor pressure. So simply lowering of vapor pressure if we take, then that will depend on the nature of solute also. So it is not a colligative property. So it means that option D is the correct answer. Then it is told 3 gram of urea is dissolved in 45 gram of H2O. 3 gram of urea 3 gram of urea is dissolved 3 gram of urea is dissolved in 45 gram of H2O. The relative lowering in vapor pressure is so now, so according to the Raoult's law, we can say that the relative lowering in vapor pressure, the relative lowering in vapor pressure, that will be equal to P naught minus PS by P naught. So P naught is the vapor pressure of the pure solvent, and PS is the pressure of the solution, and that will be given as the mole fraction of the solute. That is given as the mole fraction of the solute. So that is equal to the number of moles of solute divided by the number of moles of the solution, which is number of moles of solute plus number of moles of solvent. So here 3 gram of urea is used. So it means we have to find out the number of moles of urea divided by the number of moles of urea plus the number of moles of water that we would find. So now the molar mass of water, that is equal to 18 gram, as we know, and the molar mass of urea, that is also equal to, so urea means it is CONH2 whole 2, CONH2 whole 2. So it is 12 plus 16 plus 14 plus 2 into 2. So that will be 28 plus 16 to 2, that is 32. So this will be 40 plus 2, 20 is 60 gram. So therefore, the relative lowering in the vapor pressure, that is P naught minus PS by P naught. So that will be equal to the mole fraction of the urea. So that is the number of moles of urea. So 3 gram of urea is used. So 3 by 60 divided by, so 3 by 60 is the number of moles of urea, since why the number of moles is the weight, that is the given mass divided by m- m- molar mass. The given mass divided by molar mass will give us the number of moles of urea. So 3 by 60 divided by 3 by 60 plus the number of moles of water, that is 45 by 18. So that will be equal to how much? We have to find. So 3 12 3 20s are 60, 3 20s are 60, 9 to the 18, 5 9s are 45. So that is 1 by 20 plus this will be 50 by 20. So this is 51 by 20. So this will be equal to 1 by 51. So 1 by 51, which is approximately 0.02 millimeter of mercury column. So no, sorry, that is 0.02 not millimeter. So this is the fraction 0.02. It means the relative lowering in vapor pressure, that will come 0.02, or I can say that will be 2%. 2%. So this will be option C is the correct answer. Then here it is told which of the following solutions will, which of the following aqueous solutions will exhibit highest boiling point. So as we know that uh, the rule for elevation in the boiling point, the elevation in the boiling point, that can be written as delta TB, that is given as I into M into KB, I into M into KB. Here I is called the Van 't Hoff factor, Van 't Hoff factor, and M is the m- m- molality of the solution, molality of the solution, or we can tell the molarity of the solution, and KB is the constant. KB is the constant which is used in the elevation in boiling point. So now, so urea in urea, which is CONH2 whole 2, here the value of the Van 't Hoff factor I will be 1 only, since here the number of uh, uh, ions which will be formed, that will, so here no ions are formed, so I will be 1 only. So if no ions are formed in the aqueous solution, then the Van 't Hoff factor will be equal to 1, since no ions are formed. Since no ions are formed, so the Van 't Hoff factor will be equal to 1. So now the mo- molarity of the urea solution, that is given as 0.01. So therefore the value of I into M for urea solution, that will be 0.01 only. So from here we can see that the if since kb is a constant only, so that solution for which I into m value will be higher, for that only the elevation in its boiling point will be higher. So that solution only will have the highest boiling point. So then in case of option B, which is KNO3, so here also the I, which is the Van 't Hoff factor, the Van 't Hoff factor will be 2 here. Since why here two ions will be formed, two ions, which are one is K plus and one is NO3 minus ion. And molarity of the solution is 0.01. So the value of I into M, that will be equal to I into M, that is 0.02. Similarly for Na2SO4, for Na2SO4 solution, sodium sulfate, the value of the Van 't Hoff factor, that will be equal to 3. Since here 3 ions will be formed, means 2 Na plus ions and 1 sulfate ion, SO4 2 minus ion. And the molarity of this solution, that is also 0.01. So therefore here also the value of I into M will be 0.03. And then for the last one, which is glucose, C6H12O6. So for glucose also no ions will be formed. So the Van 't Hoff factor I will be equal to 1 only, since no ions are formed. Then the molarity of the solution, that is 0.01015 molar. So therefore here also the value of I into M, that will be equal to 0.015. So now the highest value of I into M, that is for Na2SO4 only, for sodium sulfate. So it means sodium sulfate only will show the highest elevation in the boiling point. So the boiling point of the aqueous solution of sodium sulfate only will be the highest. So option C is the correct answer. So here it is told that 5.5 milligram of nitrogen gas, 5.5 milligram of N2 gas, that is being dissolved in 180 gram of water, 180 gram of water at 273 Kelvin. At 273 Kelvin means at 0 degree Celsius, and 1 atm pressure due to nitrogen gas. So here the partial pressure of nitrogen gas, that is equals to 1 atmosphere, 1 atm, and then the mole fraction of nitrogen gas in in 180 gram of water will be how much if the partial pressure of nitrogen gas, that is equals to 5 atmosphere, then it has been asked. So when the partial pressure of nitrogen gas is 5 atmosphere, then what will be the mole fraction of nitrogen gas in the same amount of water, that is asked. So now we know that the solubility of a gas in a given solvent, in a solvent, that is proportional to the mole fraction of that gas, proportional to the mole fraction of the gas, and also the partial pressure of any gas, that is also proportional to the mole fraction of that gas. Also the partial pressure of any gas, that is also proportional to the, that is also proportional to the mole fraction of that gas. So therefore it is told that now, so 5.5 milligram of N2 means how many moles of nitrogen gas that you have to find. So the molar mass of nitrogen, that is equals to 14 into 2, that is 28 gram. So therefore here the number of moles of N2, that will be equal to 5.5 milligram, that is 5.5 to 10 power minus 3 divided by 28, these many moles. So that will be equal to 1.96 approximately into 10 power minus 4 moles. So this is the number of moles of nitrogen gas when the partial pressure of nitrogen gas, that is equals to 1 atm, 1 atmosphere. Now, so it means when the partial pressure of nitrogen gas will be 5 atmosphere, then it means the number of moles of N2 also will become 5 times. Then the number of moles of N2, that will be also equal to 5 into 1.96 into 10 power minus 4 moles. Since why as we told, partial pressure is directly proportional to the mole fraction. Now the mole fraction has been asked. So it means the number of moles will be 9.8 into 10 power minus 4 moles. Now therefore the mole fraction of N2, that will be equal to the number of moles of N2 by number of moles of N2 plus the number of moles of water. So that will be equal to number of moles of N2 is 9.8 into 10 power minus 4 mole divided by number of moles of N2 and 9.8 to 10 power minus 4 plus number of moles of H2O. Here 180 gram of water is used, so 180 by 18. So it means that initially the mole fraction of N2 was 1.96 into 10 power minus 4 divided by the number of moles of N2, 1.96 into 10 power minus 4 plus 10, since 180 by 18. So this part is approximately 10 only. So this divided by 10, so it is 1.96 into 10 power minus 5. So the new mole fraction will be 5 into that, 5 into 9. Okay. This divided by 5. So 9.8, which is also approximately same only, 9.8 into 10 power minus 5. 9.8 I can tell approximately 10. So 10 into 10 power minus 5. So it is 1 into 10 power minus 4. So option D is the correct answer. Then it is told a solution of 1.25 gram of phosphorus in 50 gram of water. 1.25 gram of phosphorus in 50 gram of water lowers the freezing point by 0.3 degree Celsius. The molar mass of phosphorus, that is 94, and Kf, which is the constant for depression in freezing point. So the Kf for water is 1.86 Kelvin kg per mole. The degree of dissociation of phosphorus in water is. So the degree of dissociation of phosphorus that is asked. The degree of dissociation of phosphorus in water. That will be how much? Okay, so here the K value is given. So we know that according to the rule of the depression in freezing point, depression in freezing point, that is delta TF, that will be equal to I into M into KF. Now here I is called the Van 't Hoff factor. The Van 't Hoff factor I, that is equal to the normal molar mass by observed molar mass. Normal molar mass by observed molar mass. So the normal molar mass is 94 and the observed molar mass that we have to find, which is equal to now phosphorus. So according to the dissociation of phosphorus, the dissociation of phosphorus will happen in this way, that is 2p, okay, means phosphorus p2 will form 2p. So here the delta t, delta t, which is the depression in the freezing point, delta TF, that is given as 0.3 degree Celsius. Now we know that delta TF, that is equals to, we can write M into KF. M is the molarity, so we can say it is KF into uh, molarity, that will be given as the number of moles, means the given mass divided by the given weight divided by the molar mass. Yeah. Given weight divided by the molar mass into the, in 50 gram of water. So it will be, so here we have to take the molality of the solution. So it is the number of moles of the solute by the mass of the solvent in kg. So the weight of water that is used, that we have to use here, which is 50 gram, and we have to keep it in kg, so it will be 50 by 1000 kg. Okay. So from here, this m is the observed molar mass. This m is the observed molar mass which we have to find out. So m, that will be equal to kf into w into 1000 by um, by 50 into delta tf. So that will be equal to kf, which is given, which is 1.86 into the given mass of the solute, that is 1.25 gram, into 1000 divided by 50 gram into delta tf, that is 0.3. So if we solve it, then we will get the value as approximately, so 50, this is 20. So if we solve it, then we will get approximately 155. This we can also cancel. So 3, 6 is 18, 3 2 is 6, 155 only we will get. So therefore the Van 't Hoff factor I, that will be the normal molar mass by the observed molar mass, which is 155. So 94 by 155, that is approximately 0.606. So Van 't Hoff factor is 0.606, and then here the degree of uh, association. Okay, here degree of association we have to find. So it means that 2p, that, so here we have to use the association of phosphorus. So 2p will form p2. So here n is equal to 2. So therefore the degree of association, that is alpha, that is given as 1 minus I by 1 minus 1 by n. So this will be 1 minus 0.606 divided by 1 minus half. So this will be half, so 0.5, and this value will be 0.4, approximately 0.4 by 0.5, so it is approximately 0.8. So 0.8 means it is approximately 80% degree of association. So we have to find the degree of association of phosphorus in water. So 80%, so option A is the correct answer. Then it is told, for an ideal binary liquid mixture, for an ideal binary liquid mixture, the rule is that, so for an ideal solution, the change in enthalpy should be equal to 0, and the change in volume delta V also should be equal to 0. And delta G, we know that that is equal to delta H minus T delta S, which is the change in Gibbs free energy. So now delta G should be negative, and the change in entropy delta S should be positive. So delta S H is 0, so delta G will be negative, so therefore delta G of the mixture, that should be negative, and change in entropy delta S of the mixture, that should be positive. So option D is the correct answer. Then here it is told that uh, After adding non-volatile solute, freezing point of water decreases to minus 0.186 degree Celsius. Calculate delta TB if KF is this, KF is 1.86 and KB is 0.521. So now delta TF, which is the depression in the freezing point, that is TF naught minus TF, that is equal to TF naught. It means the freezing point of the pure solvent, freezing point of pure water, freezing point of pure water, which is, we know that is 0 degree Celsius. So that minus this is, so this TF is the freezing point of the solution, that is minus 0.186 degrees Celsius. So that will be 0.186 degrees Celsius. Then delta TF, that will be equal to KF into M. Delta TF, that will be equal to KF into M. So delta TF is equal to KF into M. So hence from here we can find the molality, that will be equal to delta TF by KF. Now also we have to calculate delta TB, which is the elevation in the boiling point. So that will be equal to M into KB. So that will be equal to delta TF by KF into KB. So that will be equal to, so delta TF is 0.186 by KF, that is 1.86, and KB, that is 0.521. So this will be, this we can take it here, this we can shift it here, and this we can remove it. So it will come 0.1, and this will come 0.0521 Kelvin. So 0.0521 Kelvin. So option A is the correct answer. Then here it is told 0.06% aqueous solution is isotonic with. So 0.06% weight by volume solution. It means, solution of urea. It means what? It means that we have 0.06 gram of urea in 100 ml of the solution, 100 ml of solution. So therefore, now for isotonic solutions, their osmotic pressure should be same. For isotonic solutions, their osmotic pressure is same. Osmotic pressure is the same. It means that pi 1 should be equal to pi 2, and hence their molar concentration should be the same. Hence C1 should be equal to C2. It means they should have same molar concentration. They should have same molarity, I can tell, or molar concentration. So now therefore the uh, molar mass of urea, that is equals to, so urea, as you know, it is CONH2 whole 2. So it is CO, that is 12 plus 16 plus 14 plus 2 into 2. So that will be 28 plus 32, that is equal to 60 gram. And the molar mass of glucose, that is equals to, so glucose, as we know, that is C6H12O6. C6H12O6 is called glucose, and CONH2 this is called urea. So molar mass of glucose, that will be 12 into 6 plus 12 plus 6 into 16. So that is 12 6 72 plus 12 plus 96. So this will be uh, so this is 84 plus 690. So this is 180 gram. Now, therefore, the molarity of the urea, molarity of the urea solution, that will be equal to the number of moles of urea. Now, the given mass of urea is 0.6 gram, 0. Sorry, 0.06 grams. So 0.06 by 60, that is the molar mass of urea, divided by 100 ml. So we have to keep the volume of the solution in liters. So 100 by 1000. So this much molar it will be. So this should be 0.06, so 0.01 by 10. So this will be again 0.001 divided by, this is 1 by 10. 1 by 10, that is 0.1 molar. So this will be 0.01 molar. So therefore, the concentration of the glucose solution, that should be also same. Therefore, concentration of the glucose solution also should be 0.01 molar only, so as to be isotonic with this urea solution. So option D is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter solutions. Still, any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also, please install our Sapience Education application, where we shall upload some important homework questions based on the previous year KCET exam, which shall be helpful for your exam. Thank you, everyone. Bye.